Right, morning everyone. First of all, a big thank you to Terrence, Julian, and GSMA for having me here today. Just a little bit of background, I'm a full-time practicing surgeon at the National University Hospital. I specialize in liver, pancreas, and liver transplant surgery, but over the last 2-3 years, I've had the opportunity to work with GSMA implementing 5G in my hospital. So just a little bit of disclaimers and declarations. Now, the healthcare revolution, in a way, the way we see it is that it sort of mirrors the industrial revolution as well, moving from the first generation pen and paper, very memory, knowledge-intensive type of practice, to what we have now, where we are in a way at the fourth industrial revolution or the fourth healthcare revolution, looking at more and more automated systems, real-time data transfer, and the live streaming of information across the internet to different sites around the world. But of course, when it comes to innovation and AI implementation in healthcare, us as doctors and clinicians, the question is always, what is the actual benefit that it brings to the patients on the ground? Are we innovating for the sake of innovating to get the next media piece, the newspaper article on the website, or are we actually doing it so that the patients benefit from the efforts that we put in? And that comes down essentially to what is the clinical problem that we're trying to solve, how do we define it, how do we redefine it, and how do we use technology to improve the way we deliver healthcare to our patients. So one key component of all this is essentially data, right? Data is king. We used to work in silos in the healthcare sector where data is stored in the hospital. Only we could use it, and we want to extract the data from the hospital servers. It's virtually impossible. But we are no longer living in a siloed world. We're all living in a connected world now. So how do we go from paper, EMR, all the way to stream-capable networks that will allow us to transfer information at the click of a button safely and securely? So that is where the technology gap is. Data integration, computational power with more and more AI coming on, data transmission, network customizability, and scalability. How do we do this in a healthcare system? So the NUHS 5G deployment, our story began actually somewhere in 2021 when we first explored the power of 5G. And this is a speed test that we did in September 2021, looking at 4G, Wi-Fi, and a 3.5 gigahertz standalone system, outdoor system in Singapore. And at that point in time, when we were looking at 5G, we were sort of looking at it only from a data transmission perspective. How do we improve data transmission speeds? We were fortunate that we were at the right place at the right time. We were supported by the IMDA and the Singapore government to deploy the 5G solution in our hospital and to start exploring the potential of 5G in healthcare. And what we have done since then is that we have actually equipped 10 of our operating theaters with its own indoor 5G antennas. We could not use the outdoor 5G antennas for this because the operating theaters in the hospitals, they are lined by lead in the wall, right? So there's no way that your outdoor signal is going to penetrate in. We've also renovated 3 of our inpatient wards in the hospital with its own indoor 5G radio dots to essentially improve the signals indoor for us to run some of our initial pilot trials. So we did this together with Singtel and Ericsson. It was a 9-month effort to renovate the hospital because my hospital is 40 years old. We have operations running every single day. And the only time that a team from Ericsson could come in and lay the cables and drill the walls was on a Friday night and a Saturday night, because by Monday morning, the operating theaters goes back to what it does on a day-to-day basis. So it took us 9 months. The entire 5G system has been up and running in my hospital since November 2023. And what we're getting now is that in the OR, so this is a walkabout test, we are getting downlink speeds about 1,000 megabits per second with 250 megabits per second of uplink speed and a latency of less than 10 milliseconds, and we get the same amount of coverage in the inpatient wards as well. So why did we do this then? Right, a lot of times when people ask me, why 5G and not Wi-Fi, which is a lot cheaper? This is why. 5G gives us the ability to really customize our network and to rationalize the compute layers that we need in the hospital so that we can get edge computing, fog computing, cloud computing, and it's up to us how to use the different layers of compute to rationalize the applications that we onboard onto the cloud and onto the edge. Cost, speed, scaling, productivity, these are all benefits that we know comes with cloud computing, but if you overload the cloud, at some point in time, you are going to get a bottleneck in transmission, and it's still not going to work, right? So that's where we thought, okay, maybe edge computing is going to help. And this is where we work with Singtel, and right now we have a dual layer compute, where we have a edge computer at the MEC complex at a Singtel data center, and we have another layer of cloud computing in the background, where we put most of our heavy running AI algorithms on. And essentially, with 5G, it gives us the opportunity to create a fully customized network all the way from the intranet zone of the hospital, which is within our firewall, through a border control service and into the internet zone, where you can link your cloud services, your edge services, all together into one single network. This is the power of 5G that we see gives us the capability to expand our hospital network and our hospital capabilities beyond just the walls. Because now, with this network, I have the potential to link up devices across the entire country and not just within the walls of my hospital. So these are some of the customized data networks that we have developed in the hospital itself. We have multiple applications that run on the edge at the moment. So in the past, we had to use mobile workstations, huge, heavy, high-performance laptops that we had to bring around hospitals in order for us to use that as a sidecar for processing. Now, we have offloaded or uploaded everything onto the edge cloud, and essentially, we just use the 5G connectivity, run all the processes on the cloud, and you have access to that algorithm anywhere on the island, and not just with a physical laptop itself. So how do we actually use it then, right? This is one of the applications where we use the infrared camera on a mixed reality device called the HoloLens 2 from Microsoft to identify veins underneath the patient's skin. Right, so this is done in real time using AI algorithms to look at the differences between infrared signal of vein and normal skin. And those blue lines that you see, those are essentially the veins of my researchers' hands. So this is done in real time. You can tell that there is no latency, there is no lag, because the transmission of the images to the edge is instant, and the transmission of the information back onto the device is instant as well. Working with ultrasounds, live streaming ultrasound images from any ultrasound device to an AR glasses, right, where you can see holographic images. We can even do real-time three-dimensional reconstruction of an ultrasound image right at the patient's bedside. So things that you watch in the movie where they do a sweep and an image comes out, this is now a reality because we have essentially linked up the network so that it works at the patient's bedside anywhere in the hospital. And of course, one of our flagship programs, which is the use of mixed reality in healthcare, this is the very reason, or the first reason why we even went onto 5G in the first place. Because what we do with this is essentially we use 3D holograms to guide our surgery in the operating theater. Right, so this is for one of my cases for a pediatric liver transplant. This is for a 9-month-old child who was going for a transplant for liver failure. The yellow object that you see, this is the organ that was going to be donated from the mom to the child. And we use this to plan in 3D whether or not the liver is going to fit. Is it going to be too big? Where do I position the liver? Right? And all this, essentially, you need huge amounts of compute and instant access to your cloud, to your services to make sure that the information works. Right, so this is me wearing the device as I'm operating in the operating theater. And because I've already planned out before the operation how much of the liver I'm going to need for the child, there's no longer any guesswork during the surgery. Right, so we did this. We removed the excess bits of the liver. And essentially, this middle portion was the part that went inside the child. And the child is about 2 years from surgery now. She's in kindergarten. She's doing well. Right? We use this for real-time surgical navigation as well. Imagine you are Iron Man, Tony Stark, right? Moving holograms around with your hands. This is essentially what it's like to operate through this device. This is for a patient who has a tumor of the rib cage. And what we do is that we render that patient's CT scan into a 3D hologram, and we superimpose that hologram onto the patient on the operating table, and that gives us the ability to know exactly where that tumor is. The stability of the hologram and the ability of the hologram to remain in place is crucial for the surgery, because if it moves, then the registration moves and we're going to operate on the wrong spot. In order for the hologram to be very stable, you need a high-speed connection, you need low latency, you need a network that's never going to drop. And of course, you need the AI programs and AI algorithms that's in the edge and in the cloud running all the time, receiving information from the cameras that the surgeon is wearing, and at the same time processing the information and displaying the output and the images back onto those devices to tell the surgeon exactly where the tumor is. And with a touch of a button, the hologram comes back, and we know we are at the exact spot. Right? So in real time, what does it mean? Right? This is a process called remote rendering, where it converts a grayscale image into a AI segmented image to show you the different components of, for example, the CT scan. This 2 tests was done on the same day at the exact same time. On the Wi-Fi network with a remote server, it takes about half a minute for the entire process to take place. If you're going to tell a surgeon you need 30 seconds to wait for an image to appear, no one's going to use the application, because we are not very patient people, right? And as you can tell, even when the image appears, there is significant latency between the input and the response. But with 5G and edge compute, that same process takes 0.5 seconds. Same place, same time, exact same process. That is the delta that you're going to get with a brand new network and an integrated network. We have done this for remote surgical assistance as well, right? So right now what we're doing is that we have a pilot program with a charity hospital in Ghana, in Africa, where we use remote connectivity and XR device to supervise and to guide surgeons in Ghana how to do the surgery. So what I'm seeing here, what you're seeing here is a live stream of the surgeon in Ghana who was wearing the HoloLens and live streaming the images to me sitting in my office in Singapore. And I can instruct and tell them, I can even draw on their screen to let them know this is where you're going to cut, this is where you need to do, and this is how you're going to operate on the patient. We did this for 8 hours with a dedicated 4G connection on their side through GSMA Africa. On our side, we were using our enterprise 5G network, and there was not a single connection drop throughout the entire 8 hours. And the next day, right, I can even see the patients in the ward. I can hear the patients, I can listen to what they're saying, I can see the wound. And the surgeons in Ghana, what they see is that they see a holographic screen of me in front of them, and we can communicate in real time, right, with very little latency. And this essentially helps to raise the overall medical standards of this LMIC regions that we're trying to reach, instead of sending in the physical teams. And of course, as we go into more and more AI, the development of large language models, the deployment of a large language model architecture throughout the healthcare system, you need a very solid backbone of communication to ensure that your information is going to get to where it wants to go in a secure manner and it's never going to drop. And of course, now as we go more and more into things like spatial AI, making sense of the 3D world using immersive technologies, geospatial data, that's where you need more and more connectivity. Right? So in my hospital, we also have an autonomous robotics program where essentially the 5G cloud is the brain of the robot. There is nothing on the robot itself. Everything is in the cloud, and the whole thing is controlled through a 5G network. Complex digital twins, replicas of the hospital, where every single asset in the hospital becomes an IoT or an IOMT. And you put in artificial general intelligence, semantic intelligence, heuristic AI. These are the capabilities that we can now embark on our entire cloud and digital twin service because we have 5G. This is not possible in a Wi-Fi network. And it allows you to essentially integrate information from the entire country into one single data source, into one single data network. And that is a seamless transfer of data, and you don't need to have the middleware or the middleman, which we all do nowadays. Now, of course, there are a lot of challenges, right? Hardware, software, infrastructure readiness, and of course, deploying things in a brownfield in an existing hospital. It is not the easiest to try and drill a hole in the wall while someone is operating in the next room, right? And of course, the lessons that we learned, right, is invaluable in terms of how we're going to deploy this, how we're going to use this, and how this is actually going to benefit the healthcare sector as a whole moving on. Right. Now, there are many levels of implementation. I would say that right now when it comes to 5G, we are sort of like maybe level 2, level 3. We are beginning to explore and understand its true potential and its true capability, but we are not essentially maximizing it yet because there's a lot more that we can do with cellular technology when it comes to healthcare. Right? And of course, with all the different success factors, these are the things that we need to keep in mind when it comes to deploying 5G in the healthcare sector and also in any other sector as well. And this essentially is what we are working towards, right? Where your cellular network is essentially the brain and the connectivity that helps you to join every single piece of information and every single dot in your system into one true integrated network. And that's the end of my talk. Thank you, and thank you for your time.